meditation. Okay. Howdy everyone, I want to welcome you to the next Positive Gravity. I'm Doug and I'm starting a new project today. It's this big monstrosity here. So I've already got this kind of molded up. I'm going to be doing a resin casting in here. This is going to be a Yew vase. I'll show you in a minute in the video how I got to this point and what pieces are in here. So you'll get to see that. Right now, oh, it's heavy. You can see that it's pretty ugly. I put in a whole bunch of scrap wood in the top here to try to save on resin. I'm going to be pouring resin close to the top of this and then down in between these two pieces of wood. This is one piece of yew, this is another piece of yew, and I'll be pouring resin down the crack here and then filling in the top. And in the end, what I'm kind of going for will be a shape like, I don't know, maybe something like, you know, a vase, kind of like that. And there'll be a live edge up the middle here, and live edge kind of going like that. And this will all be resin, and the top will be resin. So that's, you know, something a little different than what I've done before. This is going to be a really big pour, and resin's expensive. So yeah, I put in all these filler blocks that shouldn't pose any problem. Everything's hot glued. I glued and taped this a lot. So I'm really hoping this doesn't leak. And it's just all mounted onto a piece of like plywood. So this pretty much fills my pressure pot. This is as much as I can do, more or less. So this is probably one of the biggest castings I've done. I will be using Alumilite Clear Slow with black and red metallic resin powder. I might throw some copper in actually. I have copper metallic resin powder, so I may do black and copper instead. We'll see when I get to the mixing how inspired I am to do black or red or copper. We'll see. So, all right, that's where we're going, hopefully. I'll get to pouring next and bring you back. Thanks for joining me, and don't forget, always enjoy that process. Sometimes that's all you get. So this is the yew wood that I'll be working with. This is how the tree grew. Obviously I've cut this section out of it, and there's two trunks here, and you can see that there's they were connected with a bunch of junk. I've already started taking the bark out, and so I'll just continue doing that, cleaning up these surfaces and preparing it for resin casting. Got these two pieces prepped, debarked, scrubbed. Now I just got to figure out how they went together. This. So I was thinking about doing it this way. So there'll be a resin pour in the middle. So you'll have a kind of a live edge resin pour here, and then a live edge top I don't know if I'll go higher. I can go up to about 18 inches, so I could go as high as this, but you know, you get vibration and stuff the longer you go. Those two grew together like that, so they're gonna go like that. What are the other choices? I could do it this way. I could do it horizontally. Have a resin pour through the middle there and make some sort of a tall bowl. I don't really like that idea though. I like this way better. So that's how we're going to do it. So the question is, what do we do on the top? And how do we get from here to there? I think it's too big the way it is to go in my pressure pot. It needs to be less than 12 inches, which it would be if I cut the corners off. I could probably do that on the table saw. That's how I did this one. So cut these corners off here. And here. Here. Across there. And down that side. Same thing on here. Cut that off. That would get me semi-rounded up. All right, I got this trimmed up. I just kind of nipped off the four corners. And you can see these fit together just like that. So I'm gonna go ahead and figure out how to make a mold for these. Not quite sure how I'll do it. I could just use duct tape and just tape the whole thing, maybe. And then maybe some hot glue around the bottom onto a piece of something. So I'm gonna go ahead and figure that out, and I'll bring you back once I have this ready to cast. Degas these. So this is just a vacuum chamber. I'm going to go ahead and apply the vacuum to this. So sometimes in the past I've degassed this after mixing them, but the instructions say that for best results to degas before mixing, so I've started doing that. So this is my A and B, equal parts by weight. This is Alumilite Clear Slow, and I'm applying the vacuum now. That'll start to draw the bubbles out. And the advantage of degassing this before mixing is you haven't started that clock yet. This only has about a 12-minute open time, so once you start mixing it, you only have, you know, a fairly short amount of time to get it fully mixed, degassed, and poured. So I've started doing it this way, and we'll, you know, mix it as gently as we can to try to not introduce air back into it. Alright, we're degassed. I'm going to combine these in this bigger pail. That's it there. I'm going with black. And copper. These two. And mix up the black first. Just put the rest of it in there, why not? I'm not sure that that's as opaque as I need it. So, I'm going to throw in a little bit of activated charcoal as well. This will just help ensure that it's opaque. I've never used the activated charcoal with the resin powder before, but I don't see any reason why that should be a problem. Now we're looking a lot more inky. That's good. So the idea here is to get this all mixed in, and then I'm going to add the copper at the end and not mix it as much so that I get, an uneven distribution of the copper throughout. And I won't be using nearly as much copper. It's just a highlight. Try that. That looks good, I think. Maybe just a little more copper. Woo! Now we're talking. Yeah, I think we're ready to pour. Hopefully this is enough. If it's not, I can always make more, but I don't have any more black, so I'll have to use just the charcoal. Let's hope we don't develop leaks. Come on. There we go. Nice. It's looking like gonna be good enough, I think. Perfect. Back. Beautiful. We do have some significant leaking at the bottom. I got some this flex paste, which is supposed to be good for this. And I really hope it is, because that's a pretty big leak. Got some significant leakage going on down here. Once these leaks start, they're nearly impossible to stop. This is flex paste. Which isn't working as well as I'd hoped it would. This is verging onto an unmitigated disaster here. Hope I don't have a leak going on the other side. I haven't even looked over there yet. Got to get this into the pressure pot pretty quickly here as well. Not while it's leaking. Oh God, I got leaks all over. This is bad. This is not what you want. Sort of had a feeling this might happen. This was just a really difficult mold to make. We'll get it patched up, I hope. Otherwise, we've got a very expensive mess on our hands. God. Come on, man. This stuff just wants to stick to my gloves more than it wants to stick to anything else. I think we're going to want to add some more resin to the top of this now that we've messed this up so badly. These are not working. Boy, when things go bad, they really go bad, don't they? All right, it's time to set this in the pressure pot. For better or for worse, I'll mix up a little more resin, put that in as well. Stuff's already solidifying. I missed my window for resin, for pressure. All right, well, that was a lot more dramatic than I would have liked. Definitely the worst leakage I've had on a resin pour ever. And gotta say the putty that I had used, the rubber, didn't work as well as I would have liked. I pulled this out of the pressure pot. You can see all the putty. Let's get clear of the bag here. Boy, this thing's heavy. So, you know, this worked eventually. Didn't really get too much leakage beyond what was going on before I put it in the pressure pot, so that's good. That's the good news. And the second resin pour I did on top, it looks really nice. It's nice and hard. I don't see bubbles here that are going to come into play. So the only variables really are how well this top pour blended into the bottom pour, and if there's any bubbling or anything between the two, because there was some bubbles forming on the top of the lower pour by the time I put the top pour on. So this was all very suboptimal. I'm optimistic though. I think we have reason to be hopeful. So I'm going to go ahead and demold this and have a look at the sides, and we'll start to think about getting it onto the lathe. So let's go ahead and do that. little meditation. Okay, I think we need to take a step back and recap what we've learned from this disaster. I'm still optimistic. I think we're going to have a good piece when we're done, but so far, yow. What have we learned? What's worked here and what hasn't worked here? Some things I didn't show you. So I mentioned that I baked this before I poured it. I had already put it on the plywood and I'd already taped it up and hot glued it to the bottom. It was pretty much sealed up and almost ready to pour. And I thought, I really should just bake it. Just better safe than sorry. At least some baking. So I put it in the oven. The hot glue and the duct tape should be fine up to 200 degrees. The duct tape might loosen up or the glue might get soft if I got to 200 degrees, but I stepped it up slowly from 125 to 150. I think I got up to 175 and I stopped there. It was probably in the oven for 2 hours, 3 hours. And I took it out. And at that point, it was too late in the evening, so I just put it in a plastic bag to try to keep the moisture away and came back to it the next day to do the pour. I had a feeling that it was going to leak, just my gut. It was just too messy of a mold. I should have done a better job with the mold somehow. I don't know what I would do differently, but something. And I'll have to think about that and see what I can do better next time. But as you saw, I had a lot of leakage around the bottom of the mold. I didn't really get much leakage anywhere else. That was all contained pretty well, but the bottom was leaking a lot. I'd seen in another video that there was like a rubber putty that would pretty much stop the leaking. So I intentionally went and got some of that before I did this pour expressly for that reason, because I thought I was going to have leaks. And I did, and you saw what happened with the putty. Eventually it worked, kind of, but I used the entire container of putty. That's like $15 worth of putty for this one job, and it was super messy. I mean, it was messy to put on, it was messy to take off. The rubber hardens from the outside with oxygen, so it hardens kind of from the outside in, so the rubber on the inside was still pretty not cured, and so therefore it gets messy, it gets all over your hands. And yeah, don't do that. That sucked. What else have we learned? What else have we learned? There's some bubbling around the top here, around these scrap pieces of wood, which were not baked, but I'm not too worried about that because I'm going to turn that away anyway. What else did we learn? What else did we learn? Not a big fan of this kind of plywood, or board. It's not even really plywood. I forget what you call it, but it's kind of like strips of wood that are kind of like glued together. It fractures and it's hard to cut and it's just kind of messy. It does the job, but yeah, I might opt for like regular plywood or something else on the bottom. The duct tape method worked pretty well, actually. I used hot glue under the duct tape on the edges and really didn't see much leakage out of that. All of the significant leakage was at the bottom where the glue was onto the plywood, and that did not work well. The rubber sealant material didn't stick very well to the duct tape, so where I had the duct tape and I was trying to get the rubber on, no go. So that was a big big fail there. Yeah, so a lot of lessons in this piece. I'll try to remember them all. I might have to go back and watch my own video. So not super happy with how this has gone, but it is what it is. And I still am optimistic. I think we're going to have a good piece when we're done. Right now it's still really messy. So the next step, we'll be getting it onto the lathe finally. Very exciting. All right, let's get to that step, eh? started to do some sanding here, and now I thought I would try some wet sanding on this piece. I don't typically do this, but the wet sanding lets me go up to higher grit, and that's generally good for the resin. But what I found was that the lighter colored wood absorbed a lot more water than the darker colored wood, and that caused it to swell. And then when it dried, it kind of pulled away from the resin a little bit, so I had to do some repairs. So I don't recommend this method. All right, we're gonna get back to this piece. It's been a while, it's been a few weeks. I got through the holidays, I worked on a few other things, but it's time to get back to this guy. A couple things have happened. So I didn't show it on the video, but I didn't record it. I took what was the bottom from the mold for the resin casting step. I took that off, so maybe you can see here. I just had this mounted on the lathe between centers. I turned this bottom off and I turned a tenon. So there's tenon here to hold the faceplate. The 4-jaw chuck. So our friend Chuck here is attached, and we are ready to mount this up and start our hollowing. But a piece this big, you can't just mount it up and hollow it. So before I could do that, I had to build this. So I thought I'd just share this with you guys. This is my steady rest, and it's a similar design to what you'll see. You can buy them online, you can make them, whatever. This is like 3 layers of 3/4 inch plywood. You can see the 3 layers here. And I left pockets to put in this 3/4 inch. I think those were birch, but it doesn't really matter. But that's not plywood, that's actual wood. I mounted in 4 skateboard wheels, or inline skate wheels. And for the bolts, you can buy bolts. I just went to the big box store, bought some 5/8, I think these were 5/8 inch bolts, and drilled some holes through some walnut that I turned. Actually, I drilled that out with a circle saw. Used a Forstner bit to drill a 5/8 inch hole all the way through, and then I used a larger bit to drill a hole for the head of the bolt. So there's a washer under here with the bolt, and then I just filled those with resin and made my own handles. So, and then on the back, I just have nuts right now. I think eventually I might replace these with wing nuts so I can hold on to them while I'm tightening. I didn't want to mount these bolts into the plywood because this plywood's probably not really strong enough, but I think a wing nut there would just do the job. On the bottom, so I have a hinge, I have 4 bolts for these arms which move in and out, and then I have bolts here and here, so one side can serve as a hinge, the other side can open completely either way, and then you can open it to take it on and off the lathe or manipulate it. And then for the bottom, I just got some steel plate and I've mounted a piece of steel there, piece of plywood for the center for the lathe to get it on the lathe, and then a piece of walnut, a similar bolt here. This bolt I did mount in the bottom because this is going to be under the lathe, so it's not as convenient to just grab onto. So that one's mounted in there with resin, and so I can screw this and tighten down onto the lathe bed. This piece of walnut also has a steel plate on it right there. So that's the short of it. Haven't really used it yet. I have put it on. It seems to work fine for looking at. We'll have to see if it actually helps for turning. So I'm going to mount this up on the lathe, and I'm going to mount that up on the lathe, and we're going to go ahead and start hollowing this out. The larger your Forstner bits, the slower you need to go. I think I was going about 175 RPM here. You can see those ribbons that are coming out. That's generally a good sign that you've got a decent speed for your bit. here I'm using a freshly sharpened 1/2 inch gouge, and mostly using push cuts to establish the curvature on the inside of the vase. Occasionally I'll do a pull cut, but usually it's a push cut here. Switched over here to the Easy Wood Tools Pro Series carbide hollowing tool number 1, and I did that because my gouge is very short. I need to get a new one, and I think I need to get an even longer one to do this deeper hollowing. But this carbide tool works pretty good for the hollowing, and this tool that you see here is the number 3 tool in that series. It's the most curved one. It's great for doing under the lip and around the curvature there at the top of the bowl, or the vase in this case. This is the thickness caliper that I made myself. It's easy to make one if you don't have one. I just took 2 pieces of, I think I was using thin MDF there, and made 2 layers of it, traced a curve onto it, cut both layers out at the same time so they're the exact same shape, flipped them over so that they're facing towards each other, and found the exact center, put a bolt there, and voila, you have a thickness caliper. So you can make one that's any shape you want. If you wanted to be fancy, you could do it out of sheet aluminum, or get some sheet steel and do it that way, but simple MDF seemed to work pretty good for me, and I had it lying around. So I'm still using the number 1 hollower here. That's a carbide, round carbide tip on it, and I was having some problems getting clean cutting that deep into the bowl with the tools I had. I think it's maybe just reaching past the tool rest a little bit far. I was getting some vibration that I couldn't control well with this tool. I think I need a longer handled tool to hollow this deep, and so that's on my shopping list. I'd also prefer to use a cutting edge instead of a scraping edge to do this. Maybe get a little less chipping in the resin. You can see some of the chipping there when the vase stops spinning. So yeah, cleaner cutting inside would make for less work later. I spent a lot of time sanding.